I'm now going to look at a particular type of sequence called a geometric sequence. The idea of a geometric sequence is that we multiply the previous term by a fixed constant. I can multiply by 2 every time or multiply by 1/3, as long as I multiply by a fixed constant every single time. These are going to have the form a times r to the nth power. R is going to be our ratio that we're multiplying by each time, and then a is usually our starting position. Let's look at a couple of examples. 0.5 to the nth power. If I want to write out these terms, first I have 0.5 to the first power, 0.5 squared, which is 0.25, 0.5 cubed, which is 0.125, 0.5 to the fourth power, 0.0625, and I won't keep going. And it appears that the limit as n goes to infinity of this thing is equal to 0. What if I introduce a negative? Negative 0.5 to the nth power. This time if I write out my first term, I have 0.5. My second term will be positive 0.25. My next term, negative 0.125. My fourth term, positive 0.0625. So I am alternating between signs. However, the limit of this thing is still approaching 0. While it does oscillate between positive and negative, it's still approaching 0. I start down here, I move up, down, but every time I stay closer and closer to the axis. So the limit is still 0. What about 1.5 to the nth power? Well, the first power is 1.5. 1.5 squared is 2.25. 1.5 cubed is 3.375. To the fourth power is 5.0625, etc. And you can see that these numbers keep getting bigger and bigger and bigger. In fact, the limit as n goes to infinity of 1.5 to the nth power is equal to infinity. What if we introduce the negative sign? Well, then the first term is negative 1.25, positive 2.25, negative 3.375, positive 5.0625. And so my limit before it was infinity, but it's no longer even that. Now it just flat out does not exist. It's oscillating, and this time instead of getting closer and closer to 0, I'm making these bigger and bigger jumps. So this doesn't exist. When it comes to geometric sequences, we do have a shortcut. The limit as n goes to infinity of r to the n, and in general, a times r to the n. There are 3 possible cases. It can be 0, and this is going to happen as long as the absolute value of r is less than 1, like our first 2 cases, 0.5 and negative 0.5. The limit can be 1 if r is equal to 1. In this case, we're just repeating 1 forever. And the limit could just not exist if the absolute value of r is greater than 1. These occurred in our last 2 cases, where the first one went to infinity and the second one did not exist. But don't forget that an infinite limit is still a type of divergence. In addition, this is not going to exist if our ratio is equal to -1, because then we're just going to bounce between 1 and -1 indefinitely.